Hi everyone, I'm Arshia Chabra this side, and today I'm walking you through my Lab 3 video report for Physics 2212 class at Georgia Tech. The main purpose of this lab is to study the correlation between magnetic field and observable distance both on and off axis, also study the field computationally by modeling it using GlowScript. The procedure of this experiment involves downloading the magnetometer app on your smartphone. I personally downloaded the Physics Toolbox magnetometer app. After that, determine the direction of magnetic north by laying the phone flat on table and rotating it until the magnetometer's x component equals to 0. Then set up the meter stick orthogonal to the magnetometer in order to minimize the Earth's magnetic field. Now move the phone along various distances on the meter stick and also on and off axis to record data. Then put the values recorded in the provided spreadsheet, which I'll soon show. We use a variety of physics concepts in this lab, like the bar magnet behaves like a magnetic dipole, which has a magnetic field as shown in this figure. Here the magnetic field lines go into the negative south end and go out of the positive north end, and the dipole moment is from south towards the north. We also use principles of superposition to find the net magnetic field, use the Biot-Savart law and formulas for on-axis and off-axis magnetic fields of a dipole. Also, the magnitude of magnetic field can be written as this formula. In order to get it in the slope-intercept form of y equals to mx plus b, we take the natural log of both sides of the equation to get this equation, which we can plot on the Cartesian system with natural log of b on the y-axis, natural log of r on the x-axis, natural log of k is the y-intercept, and n is the slope of the regression. When we put in the values from the experiment into the spreadsheet, we get a chart for the regression. Here the y-intercept, that is the natural log of k, is approximately equal to negative 14.3 and the slope is equal to negative 2.97. We can use these values to calculate the dipole moment and also use the other values from here in our GlowScript code. This is the Python model we create on GlowScript. First we declare the constants. Here, then we create a magnetic object representing a bar magnet at the origin. Then we calculate the magnetic field. We also find fields at 3 different locations: on axis, perpendicular to the axis, and off axis by 45 degrees. When we run the code, we get this model in which the white object is the bar magnet, the cyan arrows represent the field perpendicular to the axis, the orange arrows represent the field on axis, the magenta arrow represents the field off axis by 45 degrees. We can see that the orange arrow points in the same direction as the magnetic dipole moment, while the cyan arrows point opposite. These are the values of the fields we obtain, which clearly show that on-axis field is twice the orthogonal field. Now, answering the first what-if question, I would say that if we hadn't oriented to compensate for magnetic north, then all the readings would be biased because they would go in direction of magnetic north, because now initially the x component of the magnetometer was a negative or positive value instead of 0, which would make values of the dipole moment and thus the magnetic field less accurate or skewed. Answering the second what-if question, if we stick two identical magnets back to back, then the direction of field would be the same, and due to superposition, the magnitude of the field would be greater than that by one magnet. We can say that the magnetic field value will be approximately double in this case. Finally, we can conclude that we utilize a variety of physics concepts like the Biot-Savart law and magnetic dipoles along with computational analysis using Python to determine the magnetic field on and off axis of a bar magnet. Thank you.